As you said, I'm Dominic Galarza. I'm representing applying MBSE to AUVSI events using cloud-based tools and SE principles. So this is pretty much going to be a user success story of how we transformed a traditional document-based method of doing things to a digital MBSE and SE principle side of doing things. Here. So just a little bit of information about me. You already got it before. I'm Dominic Galarza, SPEC Innovations System Engineer. Got my BS and MS for George Mason University. And previously I've been working on requirements building, modeling, simulation, AR and VR research, everything of that sort. So to start off, back over here. To start off, AUVSI stands for the Association of Unmanned Vehicle Systems International. And so what they are is a international organization that deals with the advancement of all things unmanned technology. So whether that be through air systems, vehicle systems, land-based systems, or sea systems, they deal with the advancement and helping with research into that process. So every year they host an annual event called Exponential. And so what that is a big event hosted in California, and that allows for different companies all over the world to pretty much showcase their latest demonstrations of their unmanned technologies through demonstrations. And so before, they relied on pretty much document-based and paper-based methods to pretty much organize and execute their organizations and their events. And so that led to a lot of kind of inefficiencies, whether that be through not having the latest up-to-date information. Companies had to register for the event and then showcase their ConOps diagrams. And so before, that had to be through an actual just big poster piece of paper. And so that led to just quite a few issues where, like I said, the latest information was not up to date. And so any changes that were made throughout the process of building that ConOps diagram, an entire new diagram had to be made from scratch on the paper. Another one was that collaboration was pretty much non-existent, as everyone had to be there at the exact same time to work on this ConOps diagram. And so they proposed the need for a more modern solution. And so we stepped up and proposed that change. So you can see here, the MBSE approach was used to address these issues. And so Innoslate, the cloud-based system engineering tool, was used to fill this gap. And so Innoslate addresses these features for the following needs. A centralized data repository, so they need a single point of truth, a centralized data storage place. They needed a standard ontology. This ensured that project consistency would be ensured for all vendors. Enhanced collaboration. So obviously not everyone is able to be at the exact same place at the exact same time, all the time, even within a company. And so real-time and controlled updates were a must for them. And MBSE functionality. So on top of just making a ConOps diagram, which is a static image on a piece of paper, they needed that enhanced collaboration. So diagramming, modeling, simulation, testing of those capabilities, that was all needed as well. So to start off, we implemented a standardized ontology. And so this serves as the underlying structure for each project environment. It all starts with a ConOps diagram, that piece of paper that you would draw on. And so from there, we digitalized it, and it became a living, breathing model. And so from there, you can see how it was performed by performers. Those performers have challenges within themselves. The ConOps diagram has measures of performance and located at a certain time and has a budget. So everything just kind of stems from each other. And so the benefit from this is that with any piece of data in a project, you know exactly where it goes and how it relates to the system as a whole. And so other benefits include this consistency. As I said before, everyone follows this ontology, efficiency, and scalability. So if you have more pieces of information, you can just add it to this ontology. And if you don't have pieces of information, that's all right as well. You don't have to have it in this ontology. But again, this just serves as the foundation that every project will serve on. So MBSE in action. For the actual event organizers, they were given a master project, which had the following features. So they had access of all vendor projects. So think about it as a project, as a parent project, and each vendor was a sub-project. So the master project parent had access to all those other projects below it. And so they wanted that. They wanted quick and relevant access to their information and have real updates in real time. So if any of the vendors made an update in their project, they're able to see that in real time as it happens. And as I said before, changes made by vendors can be seen through project relationships, entities, and the history dialog as well. So any change made by any time, again, can be seen at instantly, which was very useful for them. And SE principles here include project management, change control, collaboration, and validation from stakeholders. Again, and then you can see here in this image, this is an actual screenshot of that master project. And so from there, they were able to set up exactly what they wanted at a glance in this dashboard here. So they wanted, for example, the demo reports and the assessments and the schedule for each day of the exponential event. They can also see all the stakeholders there as well. And the great thing about that is that if you click on that, you could just see that you can access that information instantly. And so on the flip side, for the event attendees, the process for data entry is now easier than ever. Now they're able to do standardized, we were able to give them standard templates. And so all they would have to do is just click into the document and input their information. No more having to process that change or anything like that. ConOps diagrams are now digital and easier to kind of collaborate with each other now. All they would have to do is just access the online tool and then just work on those changes collaboratively. And then traceable testing as well. Thanks to that ontologies I showed you earlier, you can see exactly how this ConOps diagram will relate to the system as a whole. And that relates to the other features as well, the documentation and the test cases. You can see how they're related, and you can see how they're used in this project. And again, as I said, collaborative platform for companies and organizations. So these changes can be seen in real time. Multiple users can access this at the same time as well. And these updates are just pushed automatically. And so some of the principles here include documentation, diagram building, and traceability. So here's an example of how we digitally transformed one of these ConOps diagrams and one of these posters to an actual MBSE model. So this is a paper-based document. So at the top there, you have the initial information. So you have the stakeholders involved, the resources needed, the memory joggers, the title of the poster itself. All that information can be transformed into a digital document there as seen on the right-hand side. If you move on next, then you see how the illustration, and this is one of my favorite parts here, the illustration is actually able to be into a MBSE model here. So instead of just a static image and you have to have some creative liberties to see what they're actually meaning and talking about here, you can actually drag and drop each asset onto the diagram and then specifically put in the information for each entity in this diagram here. So you can see how the canisters, the UAV is in the air, the fighter jet, the target ship, all these are actual entities that you can click on and interact with in the model. And the great thing about this too is that if you click on those entities, you can actually see its relevant information, its attributes, and you can see what it's related to in the project as a whole. So no piece of information is kind of just stuck there. And everything is able to be transformed seamlessly. And then lastly too, we have the last little bit of project information. So you have the cost, you see the timeline, the demonstration timeline, the budget, everything like that. Again, that is all able to be transformed and related to this system as a whole. So you can see on the next slide here, how each of these pieces of information is great that they're digital, and it's great that they're in the model, but how do you connect them all together? Well, through relationships and diagramming and documentation. That's how you relate them all together. So you can see how I combined all three pieces of information into one compilation document. So you see the initial information at the top there, you see the diagram kind of in the middle, and then you see lastly the budget and the timeline information on the bottom here. And so now I'm just going to run through a quick little use case of what actually happened during these events last year. So before the project or before the event even started, SPEC Innovations and AUVSI staff both worked together to create that standardized ontology. And so they were given project templates were made for each organization. So every company that registered for the event, they were then given their own blank project that they can access and then start to input their own information in there. And so as that's going on, and as the actual event day started, all users can view the event schedule for the day. And so you can see a timeline diagram there of each event happening in each day. And then specifically too, you can see the actual location and the address for each of those events as well. And so AUVSI staff actually wanted the coordinates for each event too. This was very useful for them because they were actually to allocate, before the event started, they were able to allocate spaces for each of these demonstrations happening. And then lastly too, again, as I said, vendors are able to access their needed information in their project. So you can actually see during the event, the staff were actually kind of running around with iPads and tablets, being able to quickly access their information and not had to sift through many papers or kind of search through specific things or miss, forget papers somewhere else. They were actually to just have to, they were able to have their information just on that tablet and just click it and access it. So it was very, very easy for them. And then prior to the event conclusion, as I should say, vendors were able to enter their demonstration results in the test center. So whether their measure of success actually passed, if it failed, what happened during it, they can all input that information in their test center. And so a great thing to note here is that while everyone can access that test center, not everyone can access that data. So if anyone is not shared in a project, then restricted information will appear as redacted. And so that will help for multi-level security reasons. And again, you can see an example of it, how it looks like to the right there. If they're not shared with that data and not shared with that project, they cannot see that data. And so just a conclusion, utilization of MBSE improved the following areas of workflow, efficiency, communication, and event execution. Workflow was improved by both the attenders and the attendees of Exponential. Data was very easily transferred from one organization or project to another. Multiple users collaborate at the same project at the same exact time. And now overall, just events are easier to manage and run. And so there was a great quote said, I thought exactly by who, but someone said that cloud-based tools like Innoslate aren't just for system engineering, they can also transform event management. And then lastly too, I just have a couple of illustrations of them using the tool during the event, and actually a quote by one of the AUVSI staff here. So it was a very good quote. I won't say it all, but it kind of just shows you exactly how we made an impact for this event. And thank you.
All right, any questions for Dominic? All right, no questions at the moment, Dominic.
All right, thank you very much.
Thank you. So I understand you have another presentation you're going to be doing, right?
Yes, I'm right back at it.
Okay, so but
I'm
we'll
not done
wait
just yet.
because people are switching in between rooms at the end of the half hour. So just pause for another 15 minutes then, please.
Yep, no problem. Just tell me when I'm good to go then.
All right, thank you. And I'll introduce you again.
Okay, yeah, sounds good.
All right, thanks.
You want to mute it or mute it or? Right, you don't have to. Yeah, leave it.
Yeah, no. Oh,
Appreciate you.
of course, absolutely.
Okay, I have 4 o'clock. So our next speaker is the same speaker that spoke previously. It's Dominic Galarza. He's a recent graduate of George Mason University with a BS and MS degree in systems engineering and is currently working at SPEC Innovations as a systems engineer. He has been gaining experience through his involvement in the NASA STTR Phase 2 project, where he is incorporating adaptive augmented reality to enhance pilot training and establish a unified standard operating procedure format through the lifecycle modeling language. Please welcome Dominic.
All right. Hello. Thank you very much. So welcome to my presentation, Enhancing Model-Based System Engineering Using Augmented Reality. So a little bottom line up front is that we pretty much got a HoloLens, Microsoft HoloLens 2, tested the technology, and then recorded our results. So let's begin. So a bit of context. Microsoft HoloLens 2 is an innovative leap towards augmented reality, which blends both the tangible and intangible world. Through combining the real world with artificial intelligence, we allow systems engineers to enhance their performance and efficiency using tools that allow for simulation and processes to occur in real time on a virtual platform. It's important for engineers to recognize the usability of such projects to maintain a leading edge in the field. So upon some research, there's currently no huge process with AR and MBSE, emphasizing how significant it is for us to venture out and combine AR with MBSE to better enhance our skills in the workplace. So this research here is found off of the Harvard Business Review. And so this article states that they were gains achieved by companies pilot testing and deploying AR across product development, manufacturing, training, service, and other fields in their workplace. And so this article also provides examples of augmented reality use cases and the impact it has on companies including Boeing, General Electric, DHL, Volkswagen, VPN, Xerox, Intel, and even IKEA. So here are some notable statistics. At Volkswagen, comparing CAD models to prototypes using augmented reality makes the quality assurance process 5 to 10 times faster. Intel has achieved a 29% reduction in warehouse picking time with augmented reality, and new workers are 15% faster compared to just traditional training. And first-time fix rates for Xerox technicians increased by 67% using AR, and efficiency jumped by 20%. And then you can also see some additional statistics here as well on the slide. So the Microsoft HoloLens 2 is an innovative leap towards augmented reality, again, as I stated, that blends the tangible and intangible world. So augmented reality can be used to combine the artificial world of systems engineering to further push the AI for SE initiative and improving performance and efficiency. So by having AR aid the process of visualization, collaboration, simulation, testing, and training, the capabilities of engineers are now significantly enhanced, which haven't been seen before. So here are a few examples of how the HoloLens 2 is being used in the following industries. So in the medical field, specifically for Medivis Incorporated, surgical AR, which is an application they are using, utilizes augmented reality to overlay critical diagnostic imaging directly onto the patient, allowing for medical professionals to visualize complex medical data in 3D. This enhanced visualization helps with preoperative planning, inoperative guidance, and postoperative review, potentially improving surgical precision and reducing operation time, and also enhancing patient outcomes as well. It represents a significant stride towards the future of healthcare, where digital and physical realities converge together. In the military, back in November 2018, the U.S. Army and Microsoft announced a 10-year agreement for Microsoft to provide 120 Microsoft HoloLens to soldiers. And so there's some new information about that, which I'll get to in a later part of the slide. But for the time being, the deal finally closed at $21.9 billion. And so the integration of the headsets with the military operations is a significant leap towards modern warfare and training methodologies. The HoloLens can facilitate training environments where soldiers can simulate various combat scenarios and enhancing preparedness and response strategies to real-world missions. Additionally, Analytical AI can also enhance the AR headset and can identify combat scenarios for soldiers. The investment into augmented reality in the military defense sector is a very significant process. So, which is why mixed feedback from soldiers should be taken into serious consideration. Feedback received, whether it is good or bad, should improve the process of the HoloLens as it progresses towards being a more refined product for these soldiers. And then lastly, in industry, the Arger Group Council uses the HoloLens 2 to create visual aids using animations to directly show employees their practicing and training to help assist them with guidance. So their digitalized handbook, as they call it, as mentioned by the group, can lead to the ease of processes and training for these companies. So the visualization of SOPs allow the visualization of SOPs allow the user to follow step-by-step procedures connecting to the real-world handbook and the handbook to visualize movements and actual parts that these trainees have to actually touch and interact with. So some more statistics for you. Based on the graphic here, the Microsoft HoloLens 2 is currently being used by almost 2,000 companies nationwide as of 2023, with a large majority of that market share being technical industries, educational, and manufacturing companies. And so when I say technical companies, I mean, I also include engineering firms, which also account for 21% of the market share in total, which is relatively big in the portion of the Microsoft HoloLens market. So getting more specifically into it, the HoloLens 2 can create virtual tabs in their virtual workspace through the browser. So cloud-based tools such as Innoslate can be accessed through the HoloLens directly through the browser tab. And as a result, engineers can access and create SysML and LML diagrams. They can also view and expand on CAD models and simulate their action diagrams through Monte Carlo and discrete simulators, and also create just documentation in the virtual workspace as well. This allows us to bring MBSE to the real life, further pushing AI integration and enhancing systems engineering processes here. So the HoloLens 2, as I said, can seamlessly integrate with Innoslate, capitalizing on its cloud accessibility. This allows users to access Innoslate from virtually anywhere with an internet connection through the HoloLens 2. The AR's headset multitasking capabilities enables users to run multiple instances of Innoslate simultaneously, which enhances productivity. Also, collaboration and 3D visualization can also be enhanced through this process as well. And so as a result, users can access the Innoslate projects and access their data directly through the headset without the need for a physical hardware connection. And so, as seen on this image here, this is the vision that we have for the HoloLens headsets, having multiple instances of Innoslate be able to be accessed at the same exact time. And so now let me just run you through a quick live demonstration of me using the tool, which I have in a video here. And quickly, you can see this video, right?
Yes.
Yes.
Okay, perfect. So again, this is just me accessing Innoslate and using the tool within the headset. And so you can't see it in the video, but I'm actually touching out and grabbing the space that's in front of me. And so to the headset, it's actually just me touching the screen with my finger here. And then there you can see me accessing a 3D diagram within the tool and using simulation capabilities here. So again, I'm just pinching the diagram and moving it around just with my fingertips. And again there, I'm just running a simulation through a diagram I created. And I'm seeing how it's being moved in real time there. And then for this part, I'm actually accessing the database and actually pulling up a PDF file that I saved into the project here. So by going into it, I'm going to the entity and then downloading the file, which then I can see here. Click download there, You can see the file just downloaded. So then when I open it up, I can actually open it with my fingertips and then see it right over there. And so when it pulls up, I can actually access that file and then open it up more. And again, I'm just standing here and then just pushing through this information here. Again, that's just another tab I opened. And you can see here, I'm running different instances and seeing different data. And then in this one example here, I'm actually pulling up a CAD file. So if I open up the entity over here and actually view the CAD model, it takes a little bit of time to load, but then when it does, I can actually see the model right there. And then you can see how I'm actually using my fingers to kind of move through the diagram or move through the model and see it in depth. There I'm using actually two hands to use my fingers to actually move through it. There we go. Just get back to my slide here. So upon that demonstration, you can see how no device is perfect. And so that includes the HoloLens headset. So here are a few limitations that I noticed while using the HoloLens headset in depth. So first was the hardware itself. So it is really impressively compact, but that can lead it to be being slow at sometimes. This was especially true when I was opening up different tabs and using different applications at the same time. And so the next limitation that I faced was the text-to-speech capability. While it was pretty impressive what they had, Microsoft really strangely rolled back their text-to-speech capabilities and even some of their AI capabilities as well. One of the main ones being the Cortana feature. You can actually say, "Hey Cortana," and actually use their AI capabilities. They kind of scaled that back through some recent updates for some reason. I'm not really sure why. And so the next performance gap came from the field of view. So it was relatively small compared to other headsets in the market right now, which did make it hard to see sometimes. And the last performance gap that we noticed was the hand tracking. So one of the big major selling points of the HoloLens headset was that it required no other hardware, just the headset itself. So it relied on its hand tracking and its sensors to actually notice its hand tracking capabilities. So while it is spot on for the most part, on those other times it can be a bit spotty and a bit dodgy. And then in this slide, I just wanted to show some other alternatives that are in the market right now. So the Apple Vision Pro, this one actually just released relatively recently. And so it has yet to see some huge market impact as we know it so far, but they are continually updating it as we speak right now. So this is still an ongoing and a process that's still being implemented as we speak too. The next one is a technology that's actually been here for a while. This is the Magic Leap 2. And so it's another headset released by the company Magic Leap. And so it was designed to, like the Microsoft HoloLens, blend digital content in the real world with hardware and software applications. And this is more geared towards industry and more industry capabilities. So it's being used for maintenance tasks by companies such as Boeing and AT&T. So you can kind of see an example there. That's another SOP that's being digitalized there. And the person there is kind of working on that with another hardware device that they're holding on to. So this is the part where actually I had some news recently saying how Microsoft actually canceled their plans for a HoloLens 3. So, they were kind of developing it as the HoloLens 2 was being updated and released. There were some talks about the HoloLens 3, but actually recently Microsoft made the official announcement to cancel the HoloLens 3. However, that does not mean they are canceling the HoloLens 2. They are still implementing changes, and not changes, but updates to HoloLens 2, but just its software capabilities. And just recently too, it was announced that the government contract with the HoloLens 3 or the HoloLens 2, the military use one, that contract was now canceled and is now handed to another AR company. So the HoloLens, I call it the 2.5, quote unquote. It's just a military use HoloLens. It's the exact same one as the HoloLens 2, but more geared towards soldiers and their helmet. So that one is still somewhat being updated as actual hardware has been released for soldiers, but it has had some mixed feedback, from the soldiers. So they're still kind of somewhat implementing more updates for the HoloLens 2 and softwares, but as of right now, the future for the HoloLens 3 is not very much looking good right now. I believe they said that they were willing to update the technology once more technology kind of gets released and more research gets developed into it. But as of right now, the HoloLens 3 is dead in the water. And so as a conclusion here, the HoloLens 2 itself and MBSE represents a transformative leap in the field. AR's easy access to cloud-based services such as Innoslate empowers professionals and other individuals to work from anywhere, untethered by usual hardware constraints. The HoloLens 2, its multitasking capabilities, enhances productivity and manage complex tasks with ease, with its immersive 3D visualization and collaborative features. Additionally, the headset has a lot of potential for future work and for industry workers to receive help and assistance at any time. And so in a nutshell, the HoloLens 2 leaves a positive impact in the world of MBSE. It is a testament to how far augmented reality really has come. I included a picture here of one of the first actual implementations of augmented reality. That was back in 1968. So you can see how it's been really, really just transformed over time. This is just the most recent advancement in the world of augmented reality. And it's not stopping as well. I mean, as we speak, more and more technologies are being worked on and implemented in the workforce. So this is just a little glimpse of what is to come in the future of augmented reality. And hopefully it is going to be more implemented into the world of MBSE as well. So thank you very much for the presentation. And if you have any questions, feel free to ask them.
Okay, thank you, Dom. All right, so John, we'll wait and start at the bottom of the hour.
I need to get permission to. Okay, I can share that. Okay, yeah, sounds good.
Okay, cool.
I will actually stop sharing my screen then.
Yes. I need to test if it'll work.
And
Seeing if this will actually work.
yeah, can you
I'm sure right now.
share it now?
You should hit the join virtual session button. If you're not already in.
Oh wait, here we go. Stop share. There we go.
Not sharing.
Yeah, I can see your screen.
Okay. You can see that.
Yeah.
Just testing.
This is what we see on the TV, but this is what they can see this stuff.
Yeah. Yeah. Okay. And just from our new AI tool as well.
Oh, it is?
Yeah, I knew that's true.
Thanks.
Sure, I can. Let me see what system they have set up. Okay, set it again. Okay, I'll put it up.
Okay, everybody, I have 4:30, and our next speaker is John Schatz. He supports the systems engineering team at SPEC Innovations. John earned a BA in Strategic Intelligence and National Security from Patrick Henry College. He previously supported SPEC Innovations at the Pentagon as a trained action officer in the J-36 department. Please welcome John.
Hey, thanks. So today I'm going to be talking about applying systems engineering principles to the lawmaking process, which is basically applying systems engineering principles to a non-systems engineering discipline. And as I said before, I studied intelligence studies basically at college, and I worked at the Pentagon for SPEC Innovations. And currently I support the systems engineering team for SPEC Innovations. Yeah, so just an overview of the presentation. We're going to look at the traditional lawmaking process, specifically in democratic countries, and what the problems with them are. And then we're going to look at why we should apply systems engineering principles to address those problems. And we'll specifically look at how to apply the life cycle of a law to the V model. And then we're going to look at why should we use LML to describe the lawmaking process? What benefits would LML have? And then I'll go over a model I made, an action diagram of the lawmaking process. So what are the problems with traditional lawmaking? So the traditional lawmaking process goes something like this. You have a person who comes up with an idea for a law, and then they make that law into a bill. They transcribe it into a bill, and the bill goes to a legislature who evaluates it and then will modify it usually, and then they'll vote on it. If they approve it, then it's added to the government's body of laws. So what are the problems with this? Well, for the first part, so the process lacks structure and accountability. So currently there is no requirement to clearly define like the societal problems that you're facing. There's no requirement to define measurable goals or evaluation of outcomes or anything like that. So there's not really a lot of structure to this process, and the result, additionally, there's also insufficient expertise and analysis in a lot of these. So there's no requirement that law designers know anything about law design or be experts in this field. And there's no requirement for them to use like modeling or computer simulations to test out law designs. And a lot of laws are based on, say, special interest provisions that they are included in a lot of bills, and a lot of them are based on opinions or ideology of what a law should be, rather than reliable knowledge of what the problem is and how to address it effectively. And so laws can often be ineffective or defective or vague, or just not really do the job right. And bodies of laws tend to be very complex, and a lot of them are selectively enforced just because legislators will often just add more to the body of laws to solve problems. And so why should we apply systems engineering principles to lawmaking? So first off is that lawmaking process is a system, is a functional system. And so if we think of the elements of the process as actions, then the lawmaking process is a series of actions taken to resolve societal problems. So talking about using systems engineering language to describe the lawmaking process is absolutely appropriate. But also systems thinking can help improve the lawmaking process's ability to solve problems. So one of the big benefits of systems thinking is to break down complex problems into manageable parts, which can very much help for the lawmaking process. And in the next two slides, I'm going to demonstrate how that works with the V model and how you can use it to conceptualize the life cycle of a law. So here's the law, or here's the V model, and here mapped onto it are the different components of a lawmaking process. So you start with the conception phase, identify the societal problems, and then once you've done that, you develop a concept for a new law to solve those problems. And then from there, you determine the stakeholder needs. So, for example, if you want to implement a new traffic law, you should determine the needs of, say, the drivers on the road, the police officers have to enforce this law, construction workers who have to do work on the roads. And et cetera, other stakeholders involved in it. But you get the idea, like you need to look at who is all involved in this and see what they need out of this. And then from there, you need to determine the success criteria of the law. This is basically saying if you meet these requirements, or if you meet this criteria, then the law has successfully solved the problem. Clearly define that. And then from there, you define or develop the initial requirements for the new law, and kind of like getting an idea of what the law needs to do. And then from here, you model the risks, costs, and sanctions of the law. And this is a very important section that that will help you like develop this law to be more effective. So risks are unintended consequences of a law. A very famous example would be in Prohibition era when alcohol was illegal. Most people just went underground and then created a black market. So that would be an unintended consequence of that. Costs would be like whatever costs are associated with the new law. So say financial costs to actually make the law happen, but also like opportunity costs for people who actually have to comply with it. And sanctions would be incentives to follow the law. So usually we talk about like punishments for it, like a financial penalty would be considered a sanction. And based on once you've modeled these, you can look at the requirements that you made, the initial requirements, and adjust them to improve the requirements from that. And after you've gotten the requirements down, you can write the body of the law, actually hash out the bill, and then verify the bill after that, make sure that it's all written correctly and it fills the requirements. And then assuming that the law has passed and is approved by the legislature, you want to educate stakeholders about the law so that they know what is being enforced, because you don't want to just have laws that people don't know about and enforce them. So you educate stakeholders about the law, then you enact and enforce the law. And then once you've done that for a period of time, you can validate the law, where you determine whether the law is working correctly, whether it's actually solving the problem, and then you can determine whether to extend or sunset the law, whether it should continue or just end. And so why should we use life cycle modeling language to describe the lawmaking process? Well, first off, LML is easy to understand. It was designed so that non-engineers could understand it just as easily as systems engineers. And this is important because most lawmakers are not engineers and may not know much about systems engineering. So this kind of this simple communication that LML provides is very important for this. And action diagrams specifically are uniquely suited to describe the lawmaking process. So action diagrams describe functional components of a system, and the lawmaking process is a functional system as described earlier. So action diagrams are uniquely suited to communicate the functions of the lawmaking process. So this is the lawmaking action diagram that I created. It's not necessarily perfect, but I'm still working on it. But it gives you an idea of what something like this should look like. So today we're going to look at two specific decomposed parts of this. So we're going to look at the determine risks, costs, and sanctions part of it, and then we're going to look at the validate law section. So this is the risk, cost, and sanctions model. You start with the initial requirements, you review them, and then you model the risk, the cost, and the sanctions, which should, at the end of it, generate the overall assessments from those sections. And then we'll look at the risk model here. So there are three categories to risks, which I'm going to get to in 1 second, but basically you see how you go through the different risk categories, and then they go into the outputs of that go into the determine final overall risk assessment, where you basically just like lay out what was found and then send it off to the adjust requirements section. So the three categories of risk are human rights, risk to human rights, standards of living, quality of life. So human rights, fairly self-explanatory, risks that would infringe on your rights. And then risks to standard of living, or risks to material goods that you may have, so like wealth or housing or stuff like that. And quality of life is a subjective measurement. It's basically risks to your personal happiness, your well-being, stuff like that. And we'll look at the human rights section here. Both sections, or all three sections, are the same, except you just switch out human rights for the other two. So it starts with, will this have an impact on human rights? And if it doesn't, you just move on to the end and generate that report. But if it does, you determine what level of impact will have human rights, or will have on human rights, and you determine high, medium, or low. And then the next section is, will it have a positive or negative impact? Now, risk implies that it's going to be negative, but I basically want people to think about this more deeply. So that's why I included this or entity. And now we have the cost model here, which is a bit bigger, but there are 6 sections to this, or 6 categories to the costs. So there are research and development costs, which are basically what goes into the body of the law, like the costs associated with researching and developing the law from there. And then there's a legislative process, which is actually getting this through a legislature. And then disbursement specified by law is any costs that are specified in the law that you have to disperse. Administrative and judicial includes like actually enforcing the law, and then that would include like law enforcement and the judicial process. So you got to send someone through court if they violate a law. Compliance costs are costs that would be associated with actually complying to it. So for example, if it's illegal to go over 80 miles per hour, but it's then there's a cost with, I can't get to my point A to point B without as quickly as I would be otherwise. And then quality costs of like maintaining the quality of the enforcement. And so we'll just briefly look at research and development costs. There are 5 categories here. So labor, travel, purchases, facilities, and education costs associated with researching and developing the body of the law. And some of these could be very, very definitely just be not costs that are associated with this. Like maybe there's no need to purchase anything in the making of the body of the law, but it's still something that you need to think about and address just in case for all of these. And then we'll look at the sanctions. I realize this diagram is kind of hard to see, so we're going to zoom into it in a second. But first off, there are 8 categories of sanctions that I have here: financial penalties, imprisonment, probation, community service, loss of privileges, rehabilitation, publication of violation, and capital punishment. All of these are possible incentives for why you should want to follow the law. Like, okay, if I break this traffic law, I may have to pay $1,000 in penalties, financial penalties or something. And that's the gist of it. And we'll briefly look at the financial penalty section. The other sections are the same, you just switch out the different categories. So basically determine, should we have a financial penalty, and either set it to yes or no. You can obviously set it either way, but it's something that needs to be determined specifically. And then you generate that determination after that. And then finally, we'll look at the law validation part, which is basically after you've enacted the law and you've enforced it for a period of time, you have metrics determining, okay, this is what's going on with the law, this is how it's doing. So the metrics go into review metrics, basically analyzing what's going on here. And then afterwards, you determine the applicability of the law. Should we keep this going or not? If not, you sunset the law immediately, and the law no longer is enforced, it stops immediately. But if you want to keep it going, you can extend the law, and there's an or entity here that allows you to update the law if there are any like additional updates that need to be made that would improve it. And that's all I have. Any questions?
All right, any questions from the audience? Well, it doesn't look like it. Any questions online? It doesn't look like it. Okay. Thank you, John.
All right, thanks.
For those of you online and the rest of you in the room, we're going to start trivia at 5 o'clock Eastern time. So in about 15 minutes. So there was an email that went out to talk that told you how to log into that. So I believe it's all set up, but I think, once we start it, we'll make sure everybody gets logged in to participate. All right, thank you for participating in the first day of MBSE-CON. And after trivia, we'll be finished for the day, and then tomorrow we'll resume again at 9 a.m. Thanks, everybody.
Here we